forward to Erica, who's a statistician at GLD, right? And will tell us something about geospatial data analysis.
Yeah. So I'm a statistician, but we're not going to do any statistics today. We're not even really going to be doing much data analysis today. Today's mostly about map making. So as people who study people who live on Earth, making maps is a pretty good skill. I would say of new skills to acquire, it has a pretty slow buy-in cost. So with a little bit of effort, you can gain a really big skill to help elevate both your work. So when you're writing papers, it's great to be able to actually draw a nice map of where you're studying or some interesting variable where you're studying. If you're writing grants, it's very nice. You may know every subpopulation of Uzbekistan, but your funding agency probably does not. So being able to draw people these nice visual pictures is great. We know that children love picture books, and we know that adults are just big kids. So being able to draw professional pictures is great. So we're going to be using QGIS. I'm going to record this entire presentation just so I can go a little bit faster than if I had to wait for every person to follow every step. That might be a little too hard. So if you liked this and you want to try to use it, you can go through my video and watch me click through again. I will send the organizers this website and they can circulate it around maybe. I have this note that just kind of describes what we're going to do. So maybe if you know someone who's not here who might be interested, you could send them this file and say, hey, if this is of interest to you, go ahead. And I'll put the recording down below. All of the data I'm going to use today, if you click here, it'll take you to a zip file you can download. Okay, so let's get started. QGIS stands for Quantum GIS, so Quantum Geographic Information Systems. I love it. It's very powerful and very free. So you can download it, and more importantly, anyone around the world that you collaborate with can also download it. So you can work in the same platform. Some things to know: geographic data is really big, so everything is kind of slow. And so it's also practice and patience. So 2 skills, 1 day. Okay. So how does map making work? Map making kind of works like painting, right? You start with a base canvas, and then you put layers of images on top, right? Just like you do. 1 layer of color and paint, and then another and another. So we start with this nice blank image by clicking a blank piece of paper. Okay. So what's the first thing I would want to do? I probably need some sort of background map. I don't just want to draw shapes on a white background, right? So the easiest way to do that is to use something called an XYZ tile. So here in my browser, I have this option. If I want to add a different tile, let's say I have some link to my favorite Google map, I can add a new connection, give it a name, and type in a URL. If you wanted to know where to find things like that, you can say, add Google map to QGIS. And there will be tons of links to different URLs that'll give you the maps that you want. So we're going to go ahead and just use this hybrid map. I can just double click it, and boom, I have a canvas. Okay, this isn't the thing I want to study, but it's a background that most people are familiar with, right? We know what Google Maps looks like. So let's say I want to add a map of the world to give the boundaries of all of the countries. So I said we build maps by going in layers. So I go to layer, add a layer, and then, whoa, there are a lot of options. The only 2 that you would probably need for really basic stuff, which is 90% of what you'd ever want to do, are these first 3. Vector layer, raster layer, and delimited text. Vector layers are what are known as shapefiles. So shapefiles define borders of things or individual points or lines, okay? So it's kind of the outline of a country, the outline of a district, the location of where an observation took place. Raster data is a different thing entirely. It doesn't define the region of a thing. What it does is it takes an area, say the country of Sweden, divides it into a grid with little bitty squares, and computes some statistic within each of those areas. So maybe we can compute the population within every, I don't know, half square kilometer or something, okay? So it gives me data over the space, but it doesn't define the outer border, okay? Delimited text layer, this is a fancy way to say CSV file. So when you're going to want to incorporate your own personal data about these geographic areas, you're going to want to use this one. So we're going to start with vector layer. most of the data you're going to want to use is here. So I'm going to go find one. Okay, so I have a folder that says country borders. And I downloaded this just from the internet. I Googled country shapefile into Google and I got a link. And you'll see I asked for one file, but it gave me a set of 4. These 4 files will all work together to produce the image, but I only need to choose the shapefile. My computer accidentally decided all shapefiles are PDFs. So in your computer, this should say SHP for shape. I've tried to fix it many times, but I promise. And if we click add, all right, it's popped up. Doesn't look too bad, yeah? Alrighty. Whenever you do this, so these line up pretty well, right? Like this is where Africa is in this map, right? And here it is in the Google map. They line up. The reason that these both line up is because everything is working in the same coordinate reference system, right? So we know that the Earth is a sphere, right? We all agree on that. But we know that maps are 2-dimensional, right? So we had to do something to make that globe flat. And the way we do that is through a mathematical projection. There are many different projections. They all have different pros and cons. I can send you links to YouTube videos to show you that. But the trick is we need things to match. Specifically, we need the projection here to match the projection down here. So every layer will have its own projection. So for this guy, his projection is this EPSG. Can you see that? 3857. If you're using a tile like this, its projection is fixed. You can't change it. It's built in. You cannot move it. You can change the projection of layers that you add manually, like we did up here. So for this guy, if we wanted to check what his is, what do? We go to properties, we check its source information, and we see that it is actually a 4226. Okay, well that's different, right? The last one was 3857, but everything matches up. Why is that? Well, if we look down here, here's a third reference system. This is the projection that's being used for the project as a whole. Okay? The only thing you need to make sure is that this reference system matches your base map. Okay? If these two match, you don't need to worry about any of the other ones because QGIS does what's called on-the-fly projection. So it will automatically reproject any layer you add so that things line up nicely. Okay? There are other times when you do need to be concerned about this, and we'll get to that later. But for now, we see that this projection, it will show it to me, right? 38S matches here. If I wanted to change this, I could just click this and then search for a different projection. Okay, so these work even though these have different projection systems because it's doing an on-the-fly reprojection. Okay, so this is fine, but that's a really ugly color, yeah? Can we all agree? That's not nice. So let's go ahead and try to change some visual properties of this map. So to do that, we just right-click and we go to Properties. And this is where all the magic's gonna happen. In order to change the color or just the visual look, we're gonna go to Symbology. And right now we have chosen to do a simple fill of all the countries. So this means just color the entire country one color. And right now it's like taupe. And you can go ahead and choose any color you wish. I'm gonna choose something a little more orange. Hit apply. All right, looks nice, right? It's kind of cute. Okay, in addition to the shapefile being able to draw the borders, it also holds a bunch of descriptive variables about these countries. So to do that, we need to open its attribute table. So we right-click again, we go up to attribute table, and we get a normal looking data frame. So these are all of the variables that we have to describe the countries in our map. These are just different codes for the countries and different systems. This is the UN's number of the country. Here's its name written out, right? We have the area, its population, what region it lives in, what subregion, and latitudes and longitudes. probably of some center or capital, I would imagine. So this is where things start to get interesting, because just plotting an outline and filling it with a color, that's kind of boring, right? You want to show some feature of those places, right? So what we're going to do is we can actually add a label to every country that will print its name in our map. So how do we go about doing that? Well, we need to go back to properties. So right-click, properties. I want to add a label. Right now it has no labels. I want to choose a single label. What do I want to label it with? And now I can choose whatever variable I want. I want to label it with its name. And then all of this is just changing font. So depending on how far you zoom in, you zoom out, right? What is your background color? You can choose any type of font you want. I don't want it to be too big, so let's see what this looks like. Oh, buddy. Okay, let's zoom in a little bit here. Let's see if we can't get this. Okay, now it starts to look nice, right? Okay. So every country gets its label from the attribute table. This is a really nice feature, just because a lot of people don't know what you're talking about unless you label it. Okay, so what else might we want to do? So labels are great, right? But usually we want to show some sort of variation in our data set. So maybe the way I want to color my map is actually based on its population, right? I want some sort of color gradient where darker colors mean higher population and lighter colors mean lower population. So the first thing we're going to do is we're going to get rid of these labels because they're clouding up my map. So no labels, please. Great. So we want to change the color, right? So we do that under symbology. But now we don't just want a single symbol. We don't just want one rule for everyone. We want to do graduated. So there are two options here. There's categorized and graduated. Categorized is if you want to color by a discrete variable, right? Something like maybe region or continent. Graduated is more for continuous variables, right? That will bin. So we're going to do graduated. We're going to do it by population. Okay. And then I can choose any color ramp I want. So right now it goes from light white to dark red. And then I'm going to click classify. So it has to make some sort of discrete bins, right? That's the only way that we can color on a gradient. And right now it's using 5 bins. So I see classes equals 5. So I have 5 different color groups. What's that look like? That's not very informative, right? Like, did you know this? Did you know that there's really high population in China and India? And yeah. So how can we fix this? How can we make this look a little bit better? We could increase the number of groups, right? So all we need to do is bump up. Well, why not? So do a really high number. Hit apply. Please hit apply. I made you mad. Did I make you mad? I went too fast. I told you, it's a class of patience here. All right, you should work. Classify. Apply.
I think it worked. I think it's just a beaver doesn't have enough.
Oh, you're right. Oh, you're right. So let's choose a different color ramp. You're right. It's too. Oh, I bet you if you turned those off, you would be able to see better. You're right. So pink is a hard color choice. Let's pick a different one. No, go away. Don't want you. That looks scary. This is a very nice color palette, I think. All right, let's see. Apply. No, the ocean is blue. The ocean is blue. This is why map making is important. Spectral imaging. I did one earlier that I thought was really nice. Maybe it's too many of these. Let's bring them down a little bit. Apply. No?
But I don't think that there was not so much data when you showed.
Yeah, there was. Oh, I know a better one. When we look at one country, that's why. That's why I didn't do this example. You're right. Most of them are 0. Right? We didn't have population data from 2005. I don't know what happened. But that's not a great data source. Okay, so this is if you wanted to look at all the countries. That's a little boring. Let's take a look at how these layers work. You might see that I've been toggling these things on and off. All right, that's a nice feature because you'll see when you start making maps, a lot of junk will start piling up here. It just happens. So you may want to turn them off. I don't want to see this right now. Okay. The other important thing to notice is order in this window matters. So just like the order that you apply paint to a canvas determines how the final thing looks. It's the same thing here. I can drag this below, and now I can't see him because he's underneath. He's still there. If I turn this off, there it is, but it's in the wrong order. I can't tell you how many times I've panicked because they've gotten the wrong order. I was like, my data disappeared. QGIS is broken. It's not. Just reorder it, and it's okay. Or you accidentally turn it off. That happens a lot too. So let's take a look at a more localized example. So we're going to add a new layer. So add layer, add vector layer. And now I'm going to pull up some data for Kenya. So I have a folder of Kenya administrative boundaries. And you'll see that there's different levels. So level 0, level 1, level 2, level 3, up to level 5. You guys all study political science, so you may have a better idea of what these levels mean, but they do have different definitions in different countries. So level 0 is always the country border, right? Level 1 is the next largest separation. Usually it's like a district or whatever the equivalent is in the country you're in. And then further and further localized administrative groups. So the first thing we're going to do is we're going to add in the border of Kenya. Okay, I'm going to add him. And there it is. So one of the things we haven't shown you yet is if I wanted to get to Kenya, I could zoom in manually. I could use the little plus magnifying glass. Or if I know that's what I want to see, I can right click and choose zoom to layer. And what that's going to do is that's going to center my frame around that layer. This is really, really helpful if you're working with points where observations occur. So say you did a survey and you have the latitude and longitude of every observation. When you do this zoom to layer, if something happened in the computer and the latitudes and longitudes just get really messed up, for some reason, instead of just being around Kenya, you have this really wide frame because you have this strange observation out in the middle of nowhere. So it's a nice way to make sure that you didn't miss something because you're like, oh, this is Kenya survey data. Everything should be in Kenya, right? It might not be. So zoom to layer will help you make sure that you actually see the whole picture of what got imported into the system. Okay, so this is Kenya. I don't like this kind of pink color. And actually, I just want the border, right? I don't want to cover up my beautiful Google map. So how about instead of a simple fill, I just do a simple line, okay? Typically, the default for the line width, the stroke width here, is too fine to see. So I usually bump it up to about 1.2, 1.4, hit apply. And now I can see the outline of Kenya, but I'm not covering up my beautiful base map. All right, let's add in some district level stuff. So layer, add vector layer. All right, administrative level 1, open, add, close. Okay, so now we can see that we have the districts in Kenya. Remember, we can look up their labels and just see what they are. Labels, single labels. Right. Did I not click enter? That's I didn't choose a thing. Name one. So this is the districts. Apply. Okay. And so now we see that we have all the districts in Kenya. Alrighty. So let's check out what other information this shapefile has about these districts. So how do we do that? We have to look at its attribute table. So open, attribute table. And so what do we have? We have an ID number for the country. We have other names of the country. And then we have the names of the districts, right? And then some other things. Oh, so these are provinces, I guess. These are not districts. These are called provinces. Good to know. Okay, so imagine, I actually found this data set off of the internet, and I actually want to show it to you. If you want these administrative boundaries, if that's something that you're interested in, divagis.org/gdata is a great resource. You can download data by country, so find any country you wish. And then there's different objects. I only use administrative areas here, but they have other things too. Where are the roads? Where are the railroads? What's the land cover, right? Different types of things. But if you click administrative areas, click OK, and download, you're going to get all available. So different countries have different numbers. So for Kenya, we had 6 levels, right? 0 through 5. Other countries, you might only have 0 through 2, 0 through 3. It just depends on their government structure and how much data is available. So I would definitely remember this if you're looking into making your own maps. Okay, so if I downloaded that, I was able to make this picture straight away. I didn't have to incorporate anything else to get this picture. But what if, in my research, I computed some province-level statistics, and that's what I want to put in here, right? How do I incorporate my own information into this? So if we look in my desktop, in my folder, Method Seminar, you'll see I have this additional data. So no matter what software you use, hopefully you should be able to export your data to a CSV, right? It's just a text file, right? Yes, it's fine. It's really okay. Thank you for keeping me safe. So this is, I just made up something. I want to add this new variable that gives a color for each district. That could be something more meaningful like population or GDP or I don't know, like participation in an election, something actually meaningful. But what's most important is this ID column, right? So I need a way to be able to match my data with the geographic data. So what I did is if we look at the attribute table here, we saw that there was this ID column that uniquely identified each of these provinces. Yeah? So you have to have a key, right, which is what we call for merging. So I want to merge this into that attribute table we just had open. So how do we do that? I need to import it. I need to make it a layer. So I need to do layer, add layer, but now I don't want to import a vector layer. I'm not trying to get in geographic information. I want to add a delimited text layer. I told you that's secret for CSV. So I can go find this little guy. Where are you at? So this is my additional data file. All right, and then, so I did this morning, so it cheated and it all worked perfectly. This would not happen for you. It might import as a CSV, in which case you'll see that this isn't right. It sees it all as one column. That's because CSV files in Europe are not separated by commas. It took me a week to figure that out after I moved here. It's a mean trick. They're actually separated by semicolons. So, but also, if a collaborator from the US sends you a CSV file, it might be separated by commas. So, keep track. It's probably not broken. So, I need a custom delimiter. I need it to be a semicolon. And sure enough, now I get my nice 2 columns. And I chose that there's no geometry here because there is no geometric information here, right? It's just an ID number and a color. So if I add that, nothing should happen to my map, right? Because I just added an attribute table. Okay, so what do I want to do? I want to take the attribute table assigned to this object and merge this new information to it. In QGIS, this is called joining, not merging, because you're joining the tables together. So we go to the properties, told you it's where all the magic happens, and we need to go down to joins. Okay. We want to add a join and say, okay, what are you trying to join to the current one? You say, okay, this is where we set the keys. So here they have the same name, ID1, ID1. If you had like the names of the provinces listed in both places, but they had different variables, that's okay. You can just choose the appropriate name. You don't have to rename stuff, which is kind of nice. And then if you click this, you can choose which columns in your additional data set get joined in. I don't want to replicate the ID column. That would be kind of silly. I just want the new variable part. So I click OK. I click Apply. And it seems like nothing happened, but I promise you it did. If we open, so right-click, Open Attribute Table, and here he is. So notice that in my additional data CSV file, this was just called new variable, but since I joined it from somewhere else, it first writes kind of the source, right? Where did it come from? If you want to rename them, you can, but I think it's kind of nice knowing what was original and what was separate. But if that really just gets you, you can change it. So at the end of the day, maybe you become an expert at QGIS and you run a whole bunch of commands and you get this wonderful attribute table full of great data. And maybe you want to use that in R or Stata to run some sort of model of something. I don't know. You need to be able to get this information out of QGIS in some sort of form you can put in another software, right? And that's not a shapefile, right? You can't take your shapefiles into all things. So what you can do is you can right-click, you can choose Export, Save Feature As, and then just choose the type to be a CSV file, because you should be able to import a CSV into any software you want. All right, and then just, I don't know, new attribute table. Okay. So it added it to here. That's kind of annoying. So you see how this is starting to get kind of cluttered. If I want to remove stuff, I just need to click it, highlight it, and click remove. Yes, I really mean it. Thank you. Okay. And I can even remove this too because I've joined it now. I don't need it there. Okay. Let's see. What else do we want to be able to do? I'm going to pull up my list because I had all the things I thought would be fun for you. We've gotten pretty far. Change visual properties. Okay. We want to start computing statistics, right? We want to start doing some sort of geographic aggregation of things. So to do that, I want to show you two of my favorite plugins. So there are a lot of default processes and tools that come with QGIS, and you can find them in here. So these are the geoprocessing tools, geometry tools, analysis, and data management. I guess research too. All of these come as defaults. But you'll find that there are certain things you want to do that don't come pre-installed, or you have to do a lot of steps with the pre-installed stuff to get the output you want, and it's not very efficient. Luckily, people have developed things called plugins. So it's like packages in R or modules in Python. So whenever you're trying to use QGIS, I'm guessing what you're going to do is you're going to say how to add random points to map in QGIS, right? And what you might get a hit for is something talking about a plugin, because someone already wanted to do this. And so you're going to have to go download it. So up here at the top, you'll probably see the plugins tab. If you are an Apple user, heads up, QGIS is going to be a little rough, I'm not going to lie, which is probably a lot of you, and I apologize. So maybe borrow a friend's PC. It can work, but you have to have just the right version of Python installed on your computer to make it work. I'm not an Apple user, so this might not work if you're doing that. So assuming you can get this, choose plugins, manage and install plugins. The two that I highly recommend you getting first are called N and Join. Well, I already have it installed because I like it. And what does it do? So what this one does is it joins two vector layers based on a nearest neighbor. So I have found this to be really valuable. So for me, I work with a lot of survey data, and we have these little square kilometers where the surveys are supposed to take place, right? So the enumerator is supposed to go inside, find someone who lives there, and ask to do a survey, right? So that would mean that every observation could be matched to the square where it is located. But let's be real. Sometimes the enumerators go like a little outside the square, right? Because maybe it's an apartment complex that kind of goes across the border. Or maybe the latitude longitude's a little bit off, and so it says it's a little outside. So now, how do I identify which square that observation goes in, right? What I want to do is I want to do something called nearest neighbor, right? For every observation, I want to find the nearest square, not the square it's in, because it might not actually be inside, okay? So if you want to do stuff like that, I think this is a super valuable, kind of an invaluable tool. So if you want to do nearest neighbor, there is also a built-in version. Analysis tool, nearest neighbor analysis. Okay. However, this outputs as an HTML file, so it just tells you this is the nearest one. It doesn't write that information into the attribute table. So that's kind of less helpful, right? Because I would have to take that information, save it as a CSV, re-import it, right? You could do it without the plugin, but it's a lot more steps. So take advantage of the work other people have done. The other thing that you're probably going to want is something called group stats. So if we look at group stats, so what this allows you to do is it allows you to compute statistics within the attribute table. That's a hard word, guys. In the attribute table. So let's do a little example of that. To do that, we're going to need to go to the world. Oh, hi. Can you zoom? There we go. Thank you. All right, I'm gonna delete some stuff here. Do a simple fill. White is a little stark. I don't like that. Let's do, I don't know, red's I guess kind of aggressive, but it looks muted. It's more maroon, right? All right, so what do we want to do? Let's look at this attribute table and think of something that might be of interest to us. Okay, so I have every single country and its population, say. What if I want to get the population for every region? Yeah? So I want to kind of sum together the populations of the individual countries through each region. In theory, what you could do is you could export this attribute table, read it into Stata, and do all the computations that way. You would know how to do that, or R or Python, whatever you like. Or you can just stick to one software. You can just do it all in one place. So to do that, we're going to click our group stats plugin. I think you could also find it. Oh, you can't find it there. Okay. Up here. All right. So that's kind of hard to read. So I don't love this plugin as much because it doesn't give you a really good description of how to use it, but I'm going to give you a good description now. Okay, so inside each of these three boxes, we need to describe what we want our output to look like. Okay, so the rows of our data set that we're computing, we want to be the regions, right? That's what we wanted. Alphabet is hard. Q, R, S, R, S. Come on. What? Where'd it go? Oh, I'm in the wrong one. I'm not in the world. I was in Kenya. Oh, okay, that sounded silly. Okay, so I want my rows to be the regions, right? The columns, right? What should those be? Those want to be the names, right? The different, no, wrong way. Swap. Sorry. We're just dragging and dropping. The value needs to be the population. Wait, I did it backwards. Did I do it backwards again? Erica? How did I do? I did this morning. Okay. It's the exact opposite of how I think about data. It's about called like pivot tables, right? I want the rows to be the different regions. Yes. The value should be the population. And those should be the names. Calculate. No? Oh, please. Oh, no, the value. I remember now. This got me. The column is the population, but I want the value to be the value is population. The column is the sum. It's the statistic I want to calculate. My apologies. I don't use this very often. Okay, so every region, the sum of the population, that should be the thing. Haha. Okay. Now we get our output here, right? So this is the different numbers of the regions in the map, and these are the population sums. From here, you could save these to CSVs, right? And then you could merge them into a table if you had something else. So the upside to this, I mean, it's kind of limited. It kind of depends on whether or not you just need something very quickly, right? And if you don't want to switch between softwares. But you could imagine different ways you want to do this. We could do it by instead, I don't know, we could do by subregion instead of region, right? You can do whatever you want. No reason to do sum. I mean, you could do, I don't know, counts, mins, mediums. You're kind of limited to what statistics you want. It needs to be fairly basic. Oh, unique. That sounds fun. So that's just another way to go about doing that. Let's look at another way to do coloring. So we showed you categorized last time, graduated last time by population. What if we now want to categorize the colors based on their region? All right, so this should give me colors by continent, I believe. What? Where'd you go? What? Oh, you make me so sad. Properties. Oh, I didn't hit classify. That's a good trick then, right? So you change these, we hit classify, now it actually has colors. Now we hit apply. There we go. So now they're colored by their category. Right? So all of that together, I think, is the basics of just drawing a map. So if you just wanted to show one variable in one space with some labels, it's really not that bad. This only scratches the surface of what QGIS is actually capable of. Past this, it becomes a little bit of a longer conversation, but just to give you a teaser of what you could do, let's go look at Kenya. Let's look at the Kenya border here. Okay, so let's use some of these other built-in tools. So we're going to go to Research Tools, and I want to plot some points. So I want to do random points within a layer bound. So what this is going to do is I'm going to say within Kenya, I want you to generate a lot of random points. So it's just going to randomly pick points between here. I hit run. Okay. And sure enough, I get kind of just a random scattering of points. Yeah? Not too bad. All right. So imagine that these were some sort of data points that you cared about. You might be interested. Let's see. Let's make this transparent. Make this a little nicer to see. You might be interested how many of these yellow dots are in each of these provinces, say. We could imagine a situation where that's important to us. So let's go find a tool that does that. So I don't remember the difference. Count points in polygon. That's what I'm looking for. Count points in polygon. So in this case, I know for a fact that every point lives inside one of these, right? Because I put them there. If you were using survey data where there's a possibility that someone could lie outside of these polygons, you wouldn't want to use this because certain points then wouldn't be counted, right? That's when you might want to use that n join thing I showed you. So if we do count points in polygon, one of the great things about these tools is they give these really nice descriptions of what all the inputs are. So if you are unsure of what's going on, take a check. So for us, I want my polygons to be the provinces. That's the admin 1 level. The points are my random points. And then this is going to be the name of the column in my attribute table that counts how many points are in each province. So if I hit run, that was very fast. And you'll see it generated a new layer. So this is typically how QGIS works. If you run some sort of calculation or some sort of any type of analysis, the output gets generated in a whole new layer, which is kind of annoying because this is basically this just with one extra column. So that's why keeping this tidy is really important, because when you start layering computations one on the other, you're going to end up with a big, big mess. But if we look at this attribute table, it tells us that, right, the central province had 1 dot, right? I don't know, who had the most? So if I click this, it'll organize them from smallest to largest. So he had the most. So Rift Valley. What if I wanted to find Rift Valley on the map because it had the most? So there are multiple ways I could do that. One, I have the labels up so I can find it. But what if I didn't? What could I do? Well, if you click anywhere in the Rift Valley row and you right-click, you get all of these options. And you can choose to zoom specifically to that feature. Well, and then I moved. So it zoomed into the Rift Valley. This is really useful when you're working over a very, very large space. And if you're dealing with very, very small increments, you can also ask it to flash the feature. So here it's blinking in red, so that's kind of silly. I don't know why I chose that. But you can ask it to zoom to it, or you can ask it to flash it. And it just helps you pinpoint specific polygons based on their value in the attribute table without having to like scroll and read labels and kind of go back and forth. Okay. So the only thing we haven't talked about now that might come up very quickly is wanting to compute distance between things. Yeah? So when you want to start computing distance, you're not just mapping something and coloring it or counting. The coordinate projection that you use becomes very, very important, because different projections, one, are in different units, right? And I can't measure the distance between two things if they're in different coordinate reference systems, right? They kind of have to live in the same universe. So let's see. Let's check out what's the coordinate reference system here. If I go to properties, I check the source. All right, it's a 4326. Okay. Let's generate another layer of random points, but let's just generate one random point. So we go to vector, research tools, generate random points in layer bounds. I want to generate just one point. Let's say this was something really important. This could be like a capital city. It could be some sort of like trading place. It could be a polling station. Who knows? All right. Where is it? Oh, there it is. Let's change its color because it's impossible to see it. So I don't know how it randomly generates the colors, but I don't know why does it ever choose brown? I don't know why. So it's important to know how to choose apply. Okay. So maybe what we want to do now is we want to compute the distance between all the yellow points with the purple one, right? Maybe that is some relevant variable that you need. So the first thing we need to do is we need to check that these are actually in the same coordinate reference system. The last one was 4326. Hopefully this will be the same. And it is. What if it wasn't? Okay? What if it wasn't? What would I have to do? This is what I would have to do. I have to click this layer. I have to choose layer, save as, and now I can change the coordinate reference system. Okay? So I could type in anything I wanted, right, and then save it, and it will automatically add it to my map. Okay? But let's figure out how to compute the distance really quick. Vector. No, let's do something else. We're going to do... So distance is not hard to calculate, but I want to show you something trickier. It's this nearest neighbor stuff. So nearest neighbor... Actually, we'll do a distance matrix. Okay, so the input layer is going to be... Okay, well, it doesn't matter which one's on. Target point layer just needs to be the other one. Oh, they're in the same... I gave them the same name. That was foolish. Okay, the top one, the second one, ID is the same. All right, run. Okay. So the distance matrix now, if I open this attribute table, this tells me how far every point is from the purple point, yeah? All right. So then your question is probably, what is the units on this, right? What are the units on that? And to do that, you can go to Project Properties. All right, metadata, general. It says units for distance measurements now is in meters. If you're working in a project where kilometers is more appropriate, or maybe you're working more in the US where miles will be more useful for your reader, you can go ahead and change that here. It's totally fine, and it'll do it for you. So note, distance matrix is a really heavy computation if you have a lot of points. So I recommend to use it sparingly if you can. So let's tidy up here. We kind of got a lot going on. So the last thing I want to show you is how you could subset one of these data sets if you wanted. Let's say I want to make, I can't see, this is making me dizzy. There we go. Let's say I want to make a shapefile that only has the Rift Valley in it. Yeah, just that. So the first thing I need to do is I need to select the Rift Valley. So in order to make a change or to make a selection on that layer, I need to first select it over here. So I select the administrative boundaries. And up here are all of my options for selecting. So here, I just want to select a feature, and if I click it, it gets highlighted. Okay, so now what I want to do is I want to save just this part. And it turns out that that's fairly straightforward. So if I'm highlighting this again, I do Layer, Save As, but there's this little box here, Save Only Selected Features. All right, make sure I choose a shapefile as the data type. I can choose a different coordinate reference system if I want, okay? And I can save it for use later. All right, so that's a pretty easy way to do that. There are other ways to make selections. If I want to get rid of all my selections, I just choose the yellow highlight with that. Let's say I want to select, let's go back to the world really quick. The world's going to be a better example for this. Let's say I want to select all countries whose population is bigger than something. I have no idea. So I want to make a selection based on an equation, so based on an expression. So I want all the ones where population is greater than, I have no idea what's a reasonable number for population. Oh, how many zeros is that, guys? Let's say 1 million. Okay. Okay. So select those features. And I got those. And so now I could make a shapefile in the same way of just those countries with a population over 1 million. Layer, Save As, Save Only Selected Features. Right? In the same way, I can look at the attribute table for just the things I've selected. So if I do Open Attribute Table, down here it says Show All Features. I can choose Show Selected Features, and so it will subset it for me. Anything else? So I think that's everything you would need to get started. It's a lot. Don't get me wrong. I think really the hardest part is finding the shapefiles you need. Finding that relevant data. Is there anything else that you thought you were going to learn how to do that I did not show you how to do? If you find yourself in a place, let me know. But I think that's generally it. There's a lot of help online. There's a lot of really good YouTube videos. There are tons of users, so there's nothing you should want to do that someone hasn't already done, I would imagine. Maybe a few of you. I don't know. I am not so sophisticated yet. It has met all of my needs so far. But if you ever have questions, if it's giving you a hard time, come see me, send me an email. I'm around. That's it.
Thank you.